right, guys. Um, we're in chapter 11, and chapter 11 deals with correlation between two variables. So we have gathered lots of different data. Um, we've gathered categorical data or quantitative data. We have asked two questions, and we've graphed those, or we've written those in a two-way table. Now we're going to, boy, I can't think today. We are going to ask two questions, and we're going to pair the data together. So this is going to be some kind of numerical data, some kind of quantitative data, and we're going to graph each person as their own point, and then look at all the points together in a scatter plot. So in general, you're going to get a whole bunch of points, and then we sort of draw a cloud around them, and the shape of that cloud is going to determine how correlated these two items are. So it could be, let's say, grade and shoe size. Kids in higher grades have bigger shoes. And then we end up with this association, and you can see that as grades get larger, shoe size gets larger. Or you could graph it the other way: as shoe size gets larger, grade gets larger. And so because this is going up to the right, we say that this is a positive correlation or positive association. And then anytime you have something that goes down, that would be a negative correlation. And there is a number that comes with correlation that gives us a sense of how accurate a prediction would be. So if I were to tell you somebody is in this grade, could you predict what their shoe size is? And what we do is we come up here to this line and we would say, okay, 8th grade, we predict a shoe size of, I don't know, 7, something like that, right? And the more spread out the data is in the cloud, the less accurate your prediction is going to be, right? So over here, whatever data we have there, if I ask this question, then we would predict that level. And that prediction is probably going to be more accurate because there's less spread. The cloud is less football shaped. So the number we use to describe these is called the R value. And there is a way to calculate the R value, but we're not going to do that today. We're just going to estimate it. So in general, if you have something that looks roughly like a football, that's somewhere from 0.5 to 0.7. So a football shape is roughly 0.5, 0.7. And something that is frisbee shaped is 0.8 to 0.9. But these are negatives because it's going down. If you have a perfectly straight line, then it is a 1 or a negative 1. Okay? And as your football becomes more like a circle, then you're going to get closer to 0. So if I had that and I draw my football, I can't really tell if it's going up or if it's going down. So that would have an R value of 0. Okay? So if we had something that did have a little bit of downward correlation, okay, that's more like an egg. So that would probably be somewhere between negative 0.2 and negative 0.4. Okay. So you're going to be estimating those on your worksheet today. You're going to decide, are we going up, are we going down? You need to make sure that your sign matches the up or the down. And then I've put some tape on the wall. Garrett, you're going to have to find a yardstick and get some help. So you're going to measure your wingspan and your height. and then you're going to come up here and put that in inches. So when you put your data up here, so I'm going to stick mine on there. I am 67 inches tall, and my wingspan, go figure, is 67 inches. So I'm the first data set. Okay. So when you measure it, come put it on the board. Garrett, you can use this. And then you're going to draw a scatter plot and estimate your correlation from there. Okay, any questions? All right, get to work. All right, here are all the numbers for the classroom data. So on your scatter plot, you're going to need to know what the minimum for the x-axis is and the maximum. And then on the y-axis, the minimum and the maximum, and space them out evenly. And then plot all of your points and draw the football to estimate the correlation coefficient. All right? Okay, get to work.